Hello, everyone, and welcome to another edition of Hoot. And today I'll talk about Open Policy Agent. I know we titled the stream Introduction to Open Policy Agent, and we'll talk about OPA and all that, but I'll give it an explanation from the side of Istio. Will involve Istio and see how you can use Istio and OPA together, and how Istio connects, how Istio and Envoy basically connect to OPA, and how to do all those nice things. If you're here, say hello in the chat, and we'll get started in a couple of seconds. I just make sure that I have everything that I need, and then I'll switch. Let's switch to this one. All right. So yeah, as you see, I changed the title to Istio and Open Policy Agent instead of Introduction to Open Policy Agent, but it will be, you'll hear a lot about OPA as well. So it's not just going to be Istio. All right. So what we'll talk about today is we'll talk about policies, right? So just briefly look at how you would typically do this in the past. So in the past, you'd secure the boundary of your VPC, and then you would go and segment the VPC, right? This technique, it's called micro segmentation. And what it does, it allows you to logically divide the network, right? Hello, Leonardo from Brazil. That's nice. That's far away. Hello from Seattle. So microsegmentation, you would logically divide your network into a smaller segments. You can even go down to the workload level. And then once you have these microsegments, what you would do is you would apply security policies to each segment. And you would say, oh, everyone in this microsegment 1, this is the policy that applies here. Microsegment 2, another policy, and so on. Now, if we move this to Kubernetes or even serverless, right? We know that IP addresses change, and it's really hard to keep up with the evolution of the apps in your network. Basically, you can rely on your IP addresses to drive policy or implement policy. So enter Istio. So what Istio offers, the capabilities that it offers, they're much more refined from just relying on an IP address, right? And then creating boundaries around that. So instead of just relying on the IP address, so Istio provides an identity-based model, which is the foundation of the zero trust. So what Istio does, and I think I've done talks on Spire and Spiffy in the past. If we go to our YouTube channel and look through the previous live streams, you can learn more about the Istio identity and how all that works. But for this slide here is enough to say that Istio is going to issue an X509 certificate, right, for each workload in the mesh. It's also going to manage the lifecycle of that. And then you can use that certificate, that identity, for your workload identity, basically. So you don't have to rely on your IP address anymore. Now, once you have this identity, once you assign the identity to each app or each service in your network, then you can layer on top of it things like request authentications. For example, where you have a request that can come in from the outside and can carry a JOT or OAuth token, and then it passes that token through the internal services. So at this point, we have the identity of the workload as well as the token. And then as a best practice, what you would do is you would use the combination of both of the token and the identity when you're enforcing policies. So in Istio, you can do that using the request authentication resource, right? So you can use the, for example, JOT token and identity together. Now, what is important is that you enforce these policies between your internal services as well, not just at the ingress point, right? Also, you shouldn't just pass that token that you received unrestricted through the network. Because if you do that, what it allows that to do is if basically it allows any service, even a malicious service that's in your network, that's going to see that token, they can take the token and they can replay the token against any other services or apps on the network. So one way that you could prevent that is to take that initial token and then you downscope it, right? So you exchange your existing token for a new one that's more restricted. So Istio, it gives us the ability to authenticate peers, right? To authenticate different workloads, and the ability to authenticate identities and attributes of the tokens, right? And it also allows us to do both of these at the same time, right? So with the request authentication, for example, we can assert things based on workload identity, as well as we can use the attributes of, let's say, JOT token, for example, both at the same time, right? So the combination of request authentication resource and the authorization policy resource in Istio allows us to make a, let's say, a JOT token required for requests. We can decode and validate a JOT token. We can extract the claims from the token and then use them in virtual services, for example. Now, note that this matching against JOT claims in Istio, it's currently supported in the gateways, but not between the workloads in the mesh. So let's look at an example, right? So let's say we have an API that allows us to create, or let's say update the orders, for example. So we have an endpoint like v1 orders ID, and then in the body of that request, we would have the order object, right? Something that we want to update. So the way that we want to set up our policy is to make sure that only the owner of the order can update it. So Peter can update his order, but Paul, for example, can't update Peter's order. Now, typically, when you're making decisions on whether someone is allowed to do something or not, to make updates or not, your service, in this case, this order service, would have to read some sort of storage or something in order to make a decision whether an action is allowed or not. And that decision is part of the business logic and that use case, all that's part of your service, right? That's not part of the infrastructure. So your infrastructure doesn't have any clue who or what Peter or Paul are, and it also shouldn't, right? So Istio shouldn't have to know about your business logic. However, what Istio, and to be more exact, Envoy, what they allow us to do is to call an external service and make decisions like these, right? So Istio you can parse and validate the JOT token, and then you would have a separate service or a separate something that you call out that can validate the actual claims of the JOT token. It can read from the database and can compare it to existing data. Basically, you decouple your policy from your service code. So what we've done if I compare it a little bit to what Envoy and Istio have done with the whole networking concerns, moving them out of the application into this proxy, you're doing something similar here where you're decoupling the policy, right? So orders service would have its own policy that specifies who can do what, right? Instead of hard coding that, and I'm doing air quotes here, hard coding it into your service, you decouple it from your service code and have it somewhere else, right? So my order service has no clue about Peter, no clue about Paul. However, that Envoy proxy that runs next to the service, it knows how to call an external service that has all the context, it has all the business logic, and it knows how to apply and evaluate policies. And this external service, at least in this case, is OPA. And this is what we're going to talk about today. So how does this work if we're looking at this from Istio and Envoy side first? And I'll show this in the demo. We'll see these things in the demo as well. So first of all, Envoy has a filter. So Envoy can be extended and has a bunch of filters, right, that the requests go through. One of those filters is called an external authorization filter. So this filter, if you configure it, it can be used to delegate auth decisions to an external service. Practically in the configuration, you have an IP or URL of that service, you put it into that authorization filter, and that tells Envoy to call it, right? It basically says, hey, call out to that service for auth, and you're going to get back a response that's either yes or no. It's going to be allow or deny, right? One thing that external service has to do, of course, is it has to implement Envoy's auth interface. And this interface is pretty much a single function that's called check. And that function receives the request information in the form of attributes. So there's HTTP attributes, right? The request body, the method, the path, request ID, bunch of stuff. We'll see that. So whenever Envoy calls out to this external service, it has that wealth of data, those attributes, and then it can run through a set of rules to decide whether to return an allow or to return a deny response. Right? Now, to tell Envoy to use that external service, if you're using pure Envoy, you would do it in the Envoy configuration, of course, right? Now, in Istio, the way you do it in Istio is you can define an external auth provider in mesh config. So the configuration itself is just the name of the provider, right? So you can refer to it. It can be whatever. And then the address of that external auth service, plus some options that you can set, right? So pretty much the same things that you would have to set in Envoy directly, but we're setting it through Istio. Note that there's no Envoy filters here, Envoy filter resources, so I can be more specific. No Istio Envoy filter resources involved. You don't have to specify, configure this through that. You can if you want to, but mesh config, add a provider, set the location of that provider, and then once Istio knows about the external provider, then you have to tell it when to use it, right? And the way to do that is through the authorization policy resource. So the authorization policy resource in Istio, what it does, it allows you to do access control on workloads in the mesh, and it supports 3 actions, right? It supports allow, deny, and custom. So allow and deny are self-explanatory, right? So in the authorization policy, you provide the rules, and then you say, when this evaluates to true, action is deny, meaning deny the request. Or if these rules evaluate to true and our action is set to allow, then we're going to allow the request. Basically, yes or no response, right? Now, the custom action is the one that you could use to tell Istio that, hey, I want to delegate the decision to someone out there, to an external provider, right? So if you want to use the external provider, you set that action to custom, and then you tell Istio which provider to use. So you basically refer to that provider by the name that you used in the mesh config. So this is how all of it ties together. So on the top left side, I drew that line very oddly, but what we have is a snippet from the Istio's mesh config, and this is where we created a new extension provider. We called it OPA. We're using Envoy external auth gRPC service, right? We're specifying it as gRPC. Service name is just Kubernetes' service name. So it's an OPA service running in an OPA namespace in the cluster, listening on port 9191. And there's also some additional configuration parameters that we can set. Like, for example, we want to include the request body in the check. This is something that tripped me up when I was preparing for this. I was sending a request body, and for some reason, I was just not seeing it on the OPA side. And the reason was in this setting, right? So you have to explicitly say, include the request body in the check request, right? So that's the request that gets called when when Envoy delegates the decision to an external service, right? You can also set the MAC request bytes, and you can also say, hey, send a request as bytes instead of raw, right? And then on the right side, just move this a little bit around. So on the right side, bottom right, I guess, we have the authorization policy. We're creating, this is just a typical authorization policy that you would create in Istio. We have a selector label that's targeting or selecting all HTTP bin instances in this case. We're setting the action to custom. And then we're saying, hey, our provider, the name of our provider is OPA, right? So OPA ties back to that extension provider configuration in mesh config, and all this, of course, gets translated into Envoy configuration. So that's how Envoy knows where to go for the auth decisions. Also at the bottom, we're just setting an empty rule set, and this is basically saying, hey, we want to trigger OPA for all requests to HTTP bin. Any questions so far? And note that I'll show all this in the demo as well. All right, so this was the Envoy and Istio side. So let's talk about the other side, the OPA Open Policy agent side. So what is OPA? It's a policy engine, and it features a high-level language called Rego, and that the language allows us to write our policy and rules, and basically allows us to offload that policy decision making from the service to OPA. So a couple of questions. So let's see. I wish there was a standard endpoint for external authorization validation so that any service mesh could implement this feature. Right now, this feature is only available for. Yeah, that's a good point. I don't know how this is implemented with other meshes, but yeah, I definitely agree. It would be nice if this interface was standardized, right? First of all, if it was standardized across all the proxies, maybe. But then also you have the other part of the proxies on one side and then the service mesh on the other side, right? So the service mesh would have to support it as well. So good point. What about latency? I haven't actually looked at the latency, but that's a definitely good question. So there are a couple of ways that you can deploy OPA, this policy agent. I'm going to be deploying it as a separate service that runs in the cluster, in the same cluster. However, what you could also do is you could deploy the policy agent as an extra container in your pod, right? So that way you get rid of that latency. However, that does increase the CPU and memory requests, right, on your pods. So how does it work at a very high level? This looks very similar to one of the previous diagrams or slides that I had, right? So I'm not, in this slide, I'm not assuming anything about the environments or anything about where these individual components live. So we just have some service, and that service can make requests to open policy agents. So the request is going to come into the service. Service needs to make some sort of a policy decision. The service, or in our case, in our scenario, this will be Envoy proxy, right? It's going to make the call to OPA with all that input data, and then OPA will evaluate the input against the policy and its own data. So you can also, in addition to policy and rules on the OPA side, you can also provide your own set of data, right? You can say, these users, right, have these permissions or can have this access, right? And then you can query that data from your policy, right? And then once this is evaluated, Open Policy Agent is going to send back a decision, and then the request is going to be either allowed or denied. So how do you write policies? How do these policies look like? So they're written in this high-level language called Rego, and the policy itself is comprised of one or more rules that get evaluated based on the input. So I have a simple example here. On the right side, this is what you would typically have in your policy file. So each policy file has a package name. So in our case, we're calling it ODZ, but it could be anything else. And you can also use like a dot notation to separate, like to have a full name with dots, right? My dot package dot something, right? There's also import section, right? So you can use the imports to import and use other packages. And we'll see that in the demo where I'll have an import to refer to input data. And then you have these rules, right? And these are just if then statements, right? So for example, allow if the input path equals to users. And note that that input variable is referring to the input or the request attributes, if you wish, that were sent to OPA, right? And this is the data basically from the incoming request. And then within this body of each rule, right, you can have one or more statements, right? These statements evaluate to true or false and are ANDed together, right? So if the first one is saying if path is users and method equals post, right? So assuming our input was in the input data, we had a request that was to the /users path, and it was a post method that was used, the first rule, the first allow if, would evaluate to true. Now, if you look at the second one, note that this one is named exactly the same way, right? So it's allow, right? Allow if. So whenever we have a rule name or the head of the rule, right, the same, all these rules with the same name are ORed together. So either the first rule is true or the second rule is true, then the allow will be set to true. So we have allow if path is users and method is post, or allow if path is users, user ID from the input, and the method is get. So we're basically describing two cases here. Now, the question that I had first when I saw this is, how does the OPA know, first of all, what to return, right? And how does the calling side, right, the envoy side, I guess, how does it know which value or what to look at, right, to make a decision, right? And this is where the package naming and the rule naming comes into play. So on the OPA side, and I'll show this when we deploy the deploy OPA, right? What we can do, one of the configuration settings that we can set is this policy decision path. It's called just path, right? And this can either evaluate this value, right? Notice the naming of this path. It's my dash package /stuff/allow. Now look at the bottom of the policy, the bottom of the slide where I have the policy, right? Notice the package name is my dash package dot stuff, and then we have a single allow rule in there. So this is how these two things connect, right? So the path is basically telling OPA, hey, I want, look at the result from this package and this rule, right? And what that rule can return, it can either return a true or false value. In our case, is going to be true or false, right? So allow if something is true, or and don't allow if it's not true, deny it, right? Or you can also return an object, right? So you can do a more, I guess, complex, if you wish, decisions, right? So you can return a full object, However, that object has to contain a key called allowed, and you have to set that key to true or false, right? Additionally, you can also set the headers, you can set the body and HTTP status, and all that can get passed down to Envoy and then to the service or to the user, right? And then I said in the policy, we're just using the same mypackage.stuff/allow. That's how these two things connect together. So how do you distribute these, right? So these policy files are just plain text files, right? The simplest way to do it is if you're just playing with this, if you're trying it out, testing it, and again, talking about Kubernetes, right? You create a config map with the policy file, and then you mount that config map into the OPA pod. And then in the pod or in the deployment, OPA deployment, you're basically telling the pod, hey, mount this config map and then read the policy file from this config map. Now, this has downsides, of course, right? The biggest one is that whenever you have to update the policy or whenever you update the policy, you have to restart the pod, right? Which is typically a no-go in these cases if you're updating the policy a lot, right? Another approach that OPA supports are so-called bundles, right? So a bundle is just a tarball that contains a policy and data. And what you do with this bundle, you just upload it to an HTTP server, right? So you can configure OPA to download that bundle, unpack it, right? And then use the policy from that bundle for the policy evaluation. Right? So this bundle also supports signing, so it's more secure than config map or anything else, right? Now, the only thing that you have to do to make this work is you basically configure OPA and tell it to retrieve the bundle policy from somewhere. And the somewhere can be Amazon's S3, GCP storage, Azure, OCR registry, Nginx, and so on, right? It's again, any HTTP server, right? All right, so let's go to the demo. This was all for the slides that I have. So let me do this, and I'll share my demo screen if I can find it. Terminal. I really need to figure out a solution for this. This sharing of things is getting painful. All right, there it is. I think it was this one, right? Yes. All right. Hope everyone sees the screen. And let me know if the fonts are too small or something. I can make these bigger. All right. So what do we have here? So I have a cluster. Let me just make sure that I have. Maybe let's delete stuff. Oh, perfect. I already deleted it. Authorization policy. Just make sure that I delete. Oh, A. Okay. All right. So what I have is I have a Kubernetes cluster. I have STOD installed. I have STO installed, right? And I have HTTP bin workload running in the default namespace with the proxy injected. And I think I already configured the Istio mesh, but we'll see that. So anyway, so this is exposed. So I have the IP here. So if I curl, I think it's on the example.com, just so we can try this out. Whoops. This autocomplete is not good. So let's do headers. There you go, right? So I can make a call to my HTTP bin. I get back the response, right? So this is 0, no auth, nothing configured yet. So what we'll do first is, let me just show you where I configured the provider. And notice down here, so I have the Envoy external auth gRPC service. This is the same thing that I had in that screenshot, right? We're pointing to this service that's not deployed yet, right? Port 91 and some settings, right? So let's And this is in my STO config map in the mesh config, right, in the STO system namespace. So what I'll do next is I'll actually deploy OPA. So let's create the OPA namespace. And this is the deployment that I have, right? So it's open policy agent. We're running it as a server, right? It's the address. We can do diagnostics address. Notice that path that we talked about, right? So we're saying our package is going to be called istio.oddz, and the rule is going to be called allow. So we're basically telling OPA, hey, I want you to return the true or false coming from this rule. And then just some logs that we can see. And then we have this policy Rego file, and this is being mounted from as a volume from a config map that's defined down here. So this is our config map with our very straightforward and simple policy. We're naming the package and we're setting allow variable as a default value to false, right? So what this is doing, it's just saying, hey, by default, deny all the requests, right? So let's do this and let's apply the OPA cm.yaml. Create this, and then I can just look at the bot is already up and running. And if you look at the logs, I can do deploy OPA, right? There you go. So we already have the logs here. Status log, decision state okay, discovery okay, gRPC okay, right? So all looks good. So let's do, as a next step, what we'll do is we have the policy. The other thing that we have to do is we have to configure the authorization policy, right? So authorization policy, I'll just paste it here. And it's, again, same that I had in the slide. So we're going to apply this policy to all HTTP bin workloads. We're setting the action to custom. We're setting the provider to OPA, right? We're just and then setting the rules to an empty object, basically saying, hey, for all the requests to HTTP bin, make a call to OPA, right? So let's apply this guy. Oh, so this is applied. So now if I repeat that request, this time I get a 403 forbidden, right? Remember, because we set the default allow. So we're setting everything to false. We're not allowing anything through, right? So even if I do like IP, all this is forbidden. And I'll look at the logs, and I'll see if I can copy this so we can look at how this looks like. There you go, perfect. So this is the input that was sent to OPA, and this is what OPA gets in order to evaluate the policy, right? So notice the input, notice the attributes. So this input, and I'll delete these things here just so it's easier to read. These are just the extra things that OPA adds to it. Remove this, but this is basically what you get when you're trying what's sent to OPA to evaluate as an input when evaluating the policy, right? So you get all the headers, you get the host name, method, path, protocol scheme, the time, and then source, right? So we can basically get all these attributes and use all these attributes when writing policies, right? All right, so let's make the policy a little bit more specific. So I'll go here, and what I'll do, and I'll just copy paste stuff so it's easier, and then we can talk about it. So what I'm doing here is the same package name, but I'm saying I want to import input attributes request HTTP as HTTP request, right? It's just aliasing pretty much. So I don't have to write this whole thing all the time. And if you notice, I move this here. So we have input, attributes, request, HTTP, right? So we're just aliasing that thing to HTTP request, right? So we're trying to get the access to this portion of the input. By default, we're saying deny everything, right? We're saying allow to false, and then we're saying specifically only allow if the request method is set to get and if the request path is set to /headers. So let's deploy this one. I'm just going to deploy the config map. Apply. There you go. So this is configured. Now what we have to do is we have to restart OPA so it can pick up this new new config map. Let's look at the logs. Looks like everything looks good. So what I'll do next is send a request. And this time, if we send a request to IP, it should be denied, which it is, right? It's 403 forbidden. But if we set it to headers, it could go through, and it does, right? So we get back the response. So OPA is, and we can try something like post, for example. And this is forbidden as well, right? Because we're by default, we're denying everything. This is the only thing that we're allowing, right? Now, updating this config map is tedious. So let's show how to do this with a bundle. So what I'll do is I'll delete the namespace because I'll have to redeploy OPA again. And yesterday when I was trying this, I was running into some issues. So I'm just deleting the whole namespace just in case. And then we'll deploy it again. So I have this OPA bundle file here. And let's look at this. Let's actually move this here. OPA bundle. So it's the same image. Everything's the same. The only difference here is I'm mounting this config file, and then in the config file, what we're doing is I'm setting this service to Google Storage, right? And I'm saying I have a bundle that's tied to the Google service, right? This is where that bundle is going to be. So it's going to be storage, OPA demo, OPA bundles, bundle.tar.gz, and then setting polling. And there's also other settings that you could set here. Setting the path, and then the decision and status. So basically same thing that we had previously here that we were setting directly, right? We're just creating a separate config file and then mounting that in. And then instead of mounting a policy file directly, we're saying, no. You go to this location, right? To this location, and you download the bundle yourself, right? And then you unpackage it and use that policy that's in there, right? So let's do this. So let's also look at, I'm going to complicate the policy a little bit more so it gets interesting. So let's look at the policy here. So we have a more complex policy. So let's look at what this one is doing, right? Same thing above here. We're denying it. And then we're saying, allow if this is true, this is false, right? So allow it if token is valid, allow it and token is not expired. I guess these two should be the same. And then, and the action is allowed, right? So we're basically calling three different rules here and evaluating them in this one Uber allow rule, if you wish. So first one is token valid. What we're doing here is we're using this io.jod.verify verify token method. So this is one of the packages that Rego supports and knows about, right? And we're passing in the token, and this is the signature for the token, right? Note that you should not hard code this in your policy file, right? And then what we're saying is, hey, just if this is true, like return it, right? Check if this is true and then return it. Now you might be wondering where this token variable name is coming from, right? So let's look at down here. If we go to token, so token, the way that this evaluates, or the way that we get value of this, is we're getting the authorization header. And again, this is a very simple way to split this. And we're splitting it at the space and then just getting the token value, basically, right? So it's a very, so we're getting this value, and we're saying split it by the space here and then get the token, right? You could do a better a better thing here. But anyway, this is how the token value gets assigned. So question, how does the precedence level for these rules look like? So if the rule is, I think the way it looks like, the way it looks at it, it knows which is the one that it has to evaluate first, right? Because that's what you set in, where did I have it? In here, right? So we're saying istio oddsy allow. So that one gets evaluated first. And based on that, it evaluates these sequentially, right? So it's saying, okay, allow, do I have one allow? Let's see if we have more allows. We don't, we only have one. So it goes, evaluates this one, and evaluates this one, and evaluates this one. And we know that we have, well, I know I have multiple action allowed, right? So then it's gonna, and these are ordered together, so it doesn't really matter what the order is here, right? So then it's gonna evaluate this one, or and evaluate this one, but or them together, right? So that hope that answers the question, right? So you set the entry point, and then everything gets evaluated sequentially, right? So we have the token value, right? And then over here, we're checking that the token is valid. We have another one saying if token is expired, right? So this is just showing you how to read the values from the token payload. So what is token payload? Again, we have down here, we define a token payload rule that what it does is decodes that token, and it just returns as the payload of the token. And then same thing here, right? Oh, is this an admin role? Is this an admin token, right? So we're reading the token payload, checking the role, checking if the role equals admin, checking if the role equals guest, checking if the audience equals solo.io, for example, right? And then we actually have the rules, right? These are the actual things where we're deciding whether something is allowed or not, right? So we have one that's saying, oh, check if it's the solo audience and its admin and the request method is post and the path is post and if the schema is valid. So the other thing that you can do here is, since we have a post request, right, we'll be sending a request body. We'll be sending a JSON, right, with that request. So what we could do is we could define a schema that says, oh, and it's very simple, right? We have a single property called ID with a type of string, right? And we require that ID to be there, right? So we define a schema, and note that this could be in an external file, right? I have a data.json here. We could define that schema here, doesn't matter, and then read it in, right? But we're defining a schema, and then as part of this evaluation of the rules of the policy, we can also make sure that the request body, right, the JSON that was sent conforms to that schema, right? So this is built in, right? Zero, like I don't have to write this, right? So we're just saying, hey, try to match the request body against the schema. And if it matches, if the schema is valid, then return true. If not, return false. So we can make a decision based on that as well. All right, so let's do this. Where were we? Okay, we're here. So let's deploy. I think I deleted the namespace, right? Yes. So let's create the OPA namespace. And this time I'll deploy this OPA bundle deployment and config map. It's exactly the same. The only difference is it's going to read the bundle from my Google storage, right? So let's do apply OPA bundle. And let's look at the stuff as it's up and running. And I already have a bundle there, right? But I'll redeploy it again. And what I'll use is the CLI called OPA, right? And I'll use the CLI to build the bundle. However, there's other things that you can do here. You can like evaluate a query, right? You can execute something against your input files, right? So you can do a lot of testing of your policy from here. And also you can test stuff, and I'll show this because I have a demo, and this is awesome, right? So you can test your policies, which is extremely useful, right? Because you don't want to deploy a policy without testing that policy, right? Okay, so let's do build oddsy. And oddsy is just a folder, right? So I have a folder called oddsy with this policy in there. So let's do clear OPA build .z. So this one created a bundle, right? And then what we'll do is I'll just copy this bundle to my Google storage, right? To the location that OPA knows about, right? All right, so let's look at the logs. I think we might have to wait a couple of seconds for OPA to like refresh, right? To poll for new policy, and it's going to refresh it and download it and use it. Any questions so far? Another thing that okay, so we got the bundle state okay, right? So this means that everything was good and we actually pulled the thing down. One thing that I want to share is also, let me see, I'll just paste it here. Is this website? It's playopenpolicyagent.org. And it's just a web UI where you can, it's a playground, right? You can paste in your policy, you can paste in your input, and then you can evaluate the rules, right, based on your input. So it's an extremely useful thing that I used it a lot when I was coming up with this. Okay, so this is updated. So what are we going to do next is we can try all these different policies that we define. So let me actually look at the policy because this one is complex. So let's see if the token, let's see something that's allowed first and see how it goes through, right? So we're going to do solo audience token, admin token, post to post with a valid schema. So what I did here is I created a bunch of tokens. And this is a website. This was useful as well if you're testing and playing stuff. Jot Builder, Amy Kurtz, thank you for creating this. This one allows you to create a Jot token with specific values, with specific claims, and then sign it with a specific key or secret, which is this one, the default one, right? So what I'll do is we'll send a request to hostexample.com, right? So host is going to be example.com. We're going to do, let me just do content type application JSON because we'll be sending a post request, and we'll do authorization error, and then I'll paste in this token here. So this is an admin token with a role admin. So paste this one in, and we'll do a post request, and we'll do a post request to, now I forgot the IP address. Always remember to store things in environment variables. Let's copy this guy. So post to this, to /post, right? And then we also have to pass in a JSON that conforms to this schema. So let's do this. So let's do a ID type of string. So it's some, right? Some string. This really matter. There you go. So this should work, and it does, right? So we got back. Well, we got 200 back, right? And this is just the stuff that was returned back to us, right, from the post. That's what the post endpoint returns. So this worked. So let's look at the logs from OPA. If you look at down here, right? So this was the path was ist oddsy allowed. The result was true. And then over here, we can see the method was post, the path was post. Now I moved everything. Too many logs. And then we, down here, right? You see the token that was pasted in, right? Same token. I know you can't tell, but trust me, it's the same. And then there should be a body. There you go. Parsed body ID sum string, right? So this worked, right? So a positive case. But let's see if we do, instead of string ID, right? If we do a number ID, right? So this is where this schema validation will come in. Now this time we got forbidden, right? And this is extremely powerful, right? So you don't have to figure out, like you can decouple this. It doesn't have to be in my, I'm using HTTP bin, right? I'm using HTTP bin service. I'm not touching the code of that service at all. That service has no clue what's happening in a way, right? all these decisions are delegated to OPA, right? OPA can figure this out, right? So in this case, it fails, and then we can try some other things. Let's see if we get Paul's token. Paul is not an admin, so we'll do just replace bearer with Paul's token. So this is forbidden as well, right? Because it's Paul. It's not an admin, right? It's just a guest user. However, we do have a rule that talks about the guest. So let's look at that one. Just make sure. There you go. So as guest, so get headers. We should be able to get headers. So we can do posts, right? And we shouldn't be able to do IP, for example. So let's just make sure that this works. Yeah, so this is forbidden. However, if we do get on headers, this works, right? So this is just shows you it's either this or that. Yeah, so I'm coming up to an hour almost. There's one more thing that I want to show you that was really really awesome that I saw that I did yesterday. You can also do tests. So I have this tests folder. I actually close stuff here. Don't say too many things. There you go. So I have, and this is the same. This is the same policy, right? The only thing that I did is I added these print statements, right, just so we can see some output. And then I've created tests. So what I'm doing is I have the policy underscore test.rego file in the same folder as my actual policy. And then I'm writing unit tests, right? I'm saying, oh, test that no token, if there's no token, that the request is denied. So we're basically saying, don't allow if input has these attributes, right? Don't allow if it's get headers, right? Don't allow if there's an invalid token, right? Don't allow, and I'm using an expired token here, right? If the token is expired. However, allow if the token is valid, right? And if it's get headers, and then a bunch of other scenarios as well, right? One of them is also the testing the schema validation, right? So let's try this. So the way you run this is you just do so OPA test dot and dash v, or just get verbose. So this is going to run to all those unit tests there. Boom. Pass 9 out of 9, all good. And we can look at the note that this output is because I added print statements just so we can see, right? So entering is token valid. Oh, token valid, it was undefined, so it's false, therefore it's denied, right? Same here. And then these might be more interesting, right? This goes to what Archie asked about precedence, right? You can clearly see how these get evaluated here. So it's checking if the token is valid, is checking if the token is expired, is checking if the token has the audience set to solo, it's checking if it's admin. Then it's checking the action allowed, right? Both of them are true. Then it's checking if the schema is valid. And schema is valid, right? So that a value, or it's actually this case is false, right? Jason denied because we're not providing an ID, right? And then it goes and tries to check if it's a guest, right? And that's the other is action allowed rule, right? And the same thing. So it's very. I really like this testing ability through the CLI, right? Because you don't want to be deploying these, right, without having proper tests in place. There's also a way that you can set the OPA agent or the evaluation in, I think it's either dry mode or dry run mode or audit mode or something like that, where everything evaluates to true automatically, right? However, you get all the logs, right? And then you can, based on the logs, you can go through logs and basically check if there are any issues or not. Yeah, so that was, what else did I have? I have one more slide. I just want to show that one really quickly. But I would gladly take any questions if anyone has any questions. Note that I don't claim to be an expert in this. I was playing with this for the past couple of weeks. So yeah, so this is the playground that I was telling you about. So if we do Let me see. So let's pick proper rule, right? A proper policy, and then I'm also just gonna grab an input file. So we don't have to type all that out. Oh, where is it? Bundles. This one. I think it's this one. So let's do input. Oh, it's not. Oh, it messes it up. But anything. Anyway, so if I do a simple one, let me just show you the simple one so I don't waste time. There you go. So this is a very simple one. And then in the input would look like, right, input, attributes, quest, HTTP, and I'm just going to set the method to get, and we'll set the path to headers for now, headers. And what you can do here is you can click evaluate, and I don't know why it's saying it's false, but quest, did I type it somewhere incorrectly? Put attributes, HTTP. Yeah. Anyway, something was bound to go wrong. At least it went wrong at the end. But anyway, this works well. You just have to make sure that you have the correct like input here. We can maybe I can do like input and then just say method. We'll do get, and then this one will be. We don't need this one, and we could see input. Oops. Oh, I probably don't need input. I'm guessing. I think it's just this. Yeah, there you go. Right. That was my mistake. It's just directly attributes. Let's go back. What? What? It's empty. It's not empty. What am I missing? Anyway, I'm not. Oh, there you go. It works. Okay. All right. So it's allowing it to true, and if I would set this to post evaluate, that's false, right? But yeah, this is another way that you could go and test these things. There's also examples here, right? Like you can do roles, for example, right? Where this is again, this is a better way of parsing the jot token, right? But it's doing the same thing, and you can then evaluate. Well, anyway, yeah. What else did I have here? Oh, a couple of like ecosystem and tools things. So there's this opal.ac. I haven't had time to look at it really, but it's like an administration layer for your policies, right? So this is a way to administer, right, and basically have a way to have this layer that pushes the changes to your policy, right, to all your agents, right, and updating stuff. And it also, I think, it allows you to read like from Git and from databases, right? So just a layer on top. There's also the policy registry that contains a bunch of policies that you can use, and you can build them into OCI images, right? And then have your OPA agent pull them down there. What else? Also, we support this in Glue Gateway, right? Rego Playground, and an extension for VS Code, right? And a couple of other editors. All right, well, that was it. Almost 1 hour on the dot. Hope this was useful. Please leave a feedback if you think this was useful, and leave a feedback if it wasn't. So hope people enjoyed it, and I'll see you next time. Bye, everyone.